Now that you've learned the steps to draw Lewis structures, it's time for you to practice on your own. So try all of these questions out, and don't worry, we'll go over the answers in detail.
Okay, so first we're gonna look at this here, and we have to do the C and the H. So this has 4.
Mm-hmm.
Hydrogen has a 1, but we have to multiply it by 3.
Good.
And then chlorine has 9. So we do
try that
4.
again. Hold on, try that again. For chlorine, how many valence electrons?
Oh, just kidding, 8.
Not 8.
What? Oh, 7, just kidding.
7. Mm-hmm.
There's no 9 anyway. It only goes up to 8. Okay. Okay, so 14.
Good.
And now I pick my central atom.
Mm-hmm.
So because this is like one pair and then another, I guess it's just going to be carbon and then...
Good. Keep going. You're right. Yeah.
And then the hydrogens.
Good.
And then what, I go like that?
Yep, exactly.
Okay. So then we will do this.
Mm-hmm.
And then this satisfies the octet rule. But the chlorine needs 7, so we have to do that.
Perfect. That's it. That's correct.
Okay. I'm like, oh my gosh, am I done? Okay. All right. So sulfur.
Mm-hmm.
6.
Good.
Oxygen, also 6, but times by 4 is 24.
Mm-hmm.
Right?
Yeah, you're right. You're right.
Okay. And then we have, oh, whoops. We have to take 2 away, but first we need to add them. Yeah, we're taking 2 away, right?
Think about that.
Oh my gosh, I can't believe I just did that. No, we're adding because it's a minus.
Yes.
Okay. So now we pick our central atom, which is going to be sulfur, and we put our oxygens around it.
Mm-hmm.
And then we do our bonds. And now we know that oxygen is going to have the lone pairs. And that's it, right?
That is. And then what else would we do? Keep going.
We have to add them up, and we're not going to have enough, are we?
We actually do, but this is charged. So remember, this had to have been in brackets.
Oh. And then we put 2 minus on the outside.
Good. So this structure is a tricky one, and I wanted to do this together. So that's typically what you would think that the structure would be. And you didn't do anything wrong, okay? You didn't do anything wrong. You followed all the steps perfectly. This is now going into another topic that I did want to touch on just a little bit. So this actually isn't the best structure, and there's more reasons behind this. So what you had was this. You had sulfur, and like I said, you did everything perfectly, just like we talked about. This is just a new concept. And this, I'd say, is probably one of the most common ones that they like to throw in exams. Or even like mastering chemistry, okay? So I wanted to do this one for sure. So this next concept is talking about formal charges. And what formal charges are essentially telling us is they're telling us the charge of each individual atom within the structure. Meaning we would actually know the charge of this oxygen, of sulfur, of every single oxygen within the structure. And they have to add up to that overall charge of the actual structure, so a -2. So the reason why this isn't the happiest or the best, I would say, is because there's several rules to this. And I talked about this a little bit in the notes. Let's go to this one. So part of my Lewis structure notes, well, formal charges are going to be this overall formula, where formal charges are equal to valence electrons minus the, in parentheses, the bonding electrons plus individual lone pairs. I'll explain what all this means, okay? So what I really just want you to know is to understand that basically there are specific formal charges that we prefer. So we prefer to have the central atom be 0 as a formal charge after we've calculated it, okay? The most electronegative atom prefers to be negative. And then all the formal charges, if we added them all together, they will actually equal the charge of the overall structure. So once again, the central atom prefers to be 0, and then everything else, all I'd say the most electronegative atom actually prefers to be negative. Let me explain this further. So what I'm actually going to do is I'm going to find the formal charge of each one of these atoms. So I'm going to start off with just the central atom. So I'll start off with sulfur. Now I'll say this again with the formal charge. What this is going to be, this is actually going to be the valence electrons of that specific atom. So we're saying, I'm going to say this is formal charge. So Fc, formal charge of sulfur. Okay. And then from here, I'm actually going to, here, I'll show you the formula again. I'm actually going to subtract the bonding electrons, meaning the electrons on the bond, and plus the individual lone pairs. So minus bonding electrons plus lone pairs. And it's each individual one. So individual. Okay. So for sulfur, the typical amount of valence electrons that we said it has is 6. Now, if I'm looking at the bonding electrons, how I prefer to do this is just to see how many electrons are actually touching that sulfur, are in direct contact with that sulfur. Well, there's only 1, 2, 3, and 4. I'm not talking about, the rest of these, okay? And by the way, in your book, it's going to have fractions, and I always do my absolute best to avoid teaching you guys fractions because I know it gets confusing. So in the book, just to be clear, they would have this. They would say it's the bonding electrons and then take half of that. So 1/2 the bonding electrons or half of the bonding electrons. And that would essentially be this. It would be 2, 4, 6, 8, and you chop that in half. I prefer to just teach it a different way, as I just showed you, just seeing how many electrons are actually touching or in direct contact with that atom that we're trying to get the formal charge of. So 4 in this case. Does that make sense?
Yes.
Okay, cool. So I have 4 bonding electrons. Next, I'm going to try to see, okay, well, how many individual lone pairs do I have on just sulfur? There are no lone pairs, so 0. So this is 6 minus 4. This has a +2 formal charge. This is terrible. And the reason for that is because, well, I don't want my central atom to be positive. I actually want it to be 0. That's going to be the most favorable. So that's why this structure is wrong. It's not the most favorable structure. So instead, what I would do to change this, to change the formal charge of sulfur, is I would actually move these electrons and form a double bond. And I know that sulfur is part of that expanded octet exception, so it can have more than 8 valence electrons on it. Okay, so this is fine so far. Does this make sense so far?
Yes.
Okay. Stop me at any time.
Okay.
So I'm going to do this again, and I'm going to recount this up. And what I'm trying to do is I'm trying to get that central atom to be 0, because as we saw previously, whenever we do have something that's charged, a structure that is charged, the central atom wants to be 0. This is what it prefers to be. And then the most electronegative atom, so in our case oxygen, wants to be negative.
So is this something I'm going to have to check every time I do this to make sure it's 0?
For questions like this, yes. Yeah, for I'd say like the more complicated ones, typically the ones that have charges, kind of like this, that is something I would check for. Yeah, definitely. Like, but the previous ones that did follow the octet rule and they weren't part of any exceptions, then you don't have to worry about them.
Okay.
So I'm going to keep going with this. I'm going to see once again, all right, well, how many bonding electrons do I have now since I did change this? So I have, let's see, I just added one more here. So there's 1, 2, 3, 4, 5. Okay, there's 5. So 5 bonding electrons. There are still no lone pairs on the central atom. So then this is +1. Almost there. I'm not there just yet. I want this to be 0 for the formal charge. So again, I'm going to move these electrons here. And then I'm going to form a double bond. And I'll re-find the formal charge. So now that I change this again, I'm going to see, well, how many bonding electrons do I have now? Well, now I have 1, 2, 3, 4, 5, 6. Okay, great. That's 6 bonding electrons. Plus, I have no individual lone pairs. 6 minus 6 is 0. Yay, we finally did it. So we do have a 0 formal charge. That's happy. Now I'm going to double check the oxygens. And I'm going to see how are those formal charges, because every single formal charge of those atoms have to add up to the overall charge of this structure that they gave us. So a -2. So I'm going to do this again. So now I'm going to look at oxygen, and I'm going to tell you which oxygen I'm going to look at. So I'm going to start off with just the oxygens that have a single bond. So just this one and this one. And I only have to do this once, by the way, because they're going to be the same thing. So you only do this again if there's like 2 different ones, like one has a single bond, one has a double bond. So for now, I'm just going to do the one that has a single bond. So I'm going to say O1. That just means single bond. So valence electrons, once again, oxygen typically has 6 valence electrons, so that's 6. I'm going to look at how many bonding electrons are directly bonded to oxygen. So I'm looking at this one. So there's only 1. So 1 electron directly bonded to that oxygen. And then now I'm going to count each individual lone pair or individual electron on that oxygen. So there's 1, 2, 3, 4, 5, and 6. So that's 6. And I add that up. So this is 6 minus 7. This is a -1. That is totally fine that it's a -1 because we want our electronegative atom, which is oxygen in this case, to be negative if possible. Okay, it's going to add up. It's going to be fine. So this one would also be -1 because it's the same exact thing, right? This is a single bond. It has the same number of electrons. That's fine. This is also a -1 formal charge. I'm also going to check this oxygen since that has a double bond. So now I'm going to look at the one, I'm going to say O2, just saying there's a double bond, and recount this up. So I'm going to look again at the bonding electrons. So the electrons directly bonded to that oxygen. I'll put this in blue. So this is 1 and 2, so just 2 bonding electrons. I'm going to add each individual electron here. So let's do yellow. So individual, again, this is 1, 2, 3, and 4. This gives us 6 minus 6, so that's 0, which is fine in this case, and I'll explain why. So we said the central atom was 0. That's what it prefers to be, so good. And then next, this oxygen, these two are -1, and then these are 0 and 0. If we were to count actually add up all of the formal charges together, it does give us a -2 charge, because this is 0 plus -1, plus 0 plus 0 plus -1. Really what we're doing is -1 plus another -1. That gives us an overall -2 charge. So that checks out. This is the right structure. Questions?
No, that's a lot.
I know.
It's just a lot of work. It's not like
it's a lot of work. It's a lot of work. Yes, it absolutely is. When you do this enough, you'll be able to be faster at this, and I wouldn't say not need the formula, but you'll be able to do the formula in your head. Not that I expect that from you right off the bat, okay? But it will get faster. But just know that whenever you add, actually kind of like what we did in the very beginning, sulfur started off with a +2 charge. By changing the bonds, so like by basically making this into a double bond that decreased the formal charge to +1. I added another double bond and that decreased it again to 0. So kind of like picking up on that trend, if the central atom is a positive and you can actually start there, then you know that the structure is wrong. And that's actually what I would say to start. Instead of having to do everything around it, just know, how can I make the central atom happy? How can I make that have a formal charge of 0? And once that does, it most likely is correct. All right, so this would be the overall structure. And I wanted to introduce that at least a little bit today because we will be going over that again. But perfect. Okay. So the next ones I'm going to have you continue on.
Okay. So we have nitrogen. Nitrogen has 1.
Good.
Okay, so our central atom is nitrogen.
Perfect. That's right. Good.
Okay. This falls into our exceptions, doesn't it?
It's possible. If it's needed, yes, it does. But that's only if the structure needs to have an expanded octet.
Okay. Oh, just kidding. Okay. Ooh. Yeah, I'm not doing that. Don't judge me. I can't do quick math. Okay. Now we have to add
Good.
1.
Beautiful.
And it needs to always be even, so. Okay. So now we will take bromine. Do our 3 oxygens. And the oxygens are going to wait. Is that right?
You're good so far.
Okay. Okay. But bromine is not satisfying the octet rule.
Good.
And 8 times 3 is 24, not 26, so we need to add 2.
Perfect. What else do we need to do?
Oh, yeah.
Cool. Now, this is still applying what I just taught. And Melissa, and you immediately look down like, no. Why?
But like, so because I saw the charge, that should have been my indicator, hey, I need to check on the bromine.
That and the fact that bromine is part of the exceptions, yes. Yeah.
Okay.
So definitely the charge, definitely it's in the exception. And we saw that again with question 2 because it was sulfur. Sulfur is also part of our exceptions and it had a charge. So what I want you to do first is just find the formal charge of the central atom, so bromine. And I'll walk you through it. So again, the formula, if you want to write this down, you can just put like FC, so formal charge is equal to, valence electrons. Minus, parentheses, bonding electrons. Good, and then plus, and let's just say individual lone pairs. You could also think of it as individual electrons, but I just said lone pairs. Cool. So go ahead and by the way, it's not B, it's BR. Formal charge of BR. Yeah, good.
Thanks.
So valence
Okay.
electrons. Go for it.
Okay, so the valence electrons of bromine is going to be 7. Oh, whoops. 7.
Good.
Minus the bonding electrons, which is just the ones touching it. So do I include these?
No, so those would be the individual lone pairs. So bonding
Oh,
electrons
okay.
are the electrons in the bond.
That makes sense. Okay, so there's going to be 3 of those
Good.
plus 2 individual.
Yes.
Right,
Good.
okay.
That's right.
So 7 minus 5 is 2.
Exactly. So because that has a +2 charge, formal charge, it's not happy. It wants to be 0. So this is similar to the last thing we did, where we started adding double bonds to reduce the formal charge of the central atom to 0. So we want to do that again. So doesn't matter which oxygen you choose, go ahead and move 2 electrons and then change that to a double bond.
Okay.
And then we can recount and then double check, okay, does this give us 0?
So now we have
Good.
Wait, what just happened? I got 5 now.
Hold on. Parentheses first, then subtract. Oh,
Yeah,
that's
7.
adding. Sorry. 4 plus 2. So the formula is bonding electrons plus. Yeah.
I messed up the formula. I'm like, what just happened? Okay. This is literally my life. Do you see what goes on? Okay. All right, so it's 1.
Good. It's 1. Yeah.
All right.
So it's not 0 just yet. Yep. So what do we have to do now?
Do it again.
Exactly.
Oh,
Good.
Jeez.
Oh, it was fine. I've seen funkier Lewis structures. You're totally fine.
Okay, so the bonding electrons now is going to be 1, 2, 3, 4, 5.
Good.
Plus 2
Perfect.
equals 0.
Exactly.
So now we're happy.
Now we're happy. So if we truly wanted to, and I won't make you, so don't worry. But this essentially is the main thing that I want you to check for. If you were in a time crunch, definitely just check the central atom and make sure that that's 0, and most likely that will be the best structure. Now, if you had plenty of time, of course, checking the formal charge of every single atom is going to be important. So if we were to do that, you would actually see that the oxygen with the single bond would have a formal charge of -1, and then the ones that have a double bond have a formal charge of 0. So that's why everything adds up to the overall charge of -1, which is what we wanted. So that's why this does check out.
So it's just a way of like double checking kind of yourself.
Exactly. Perfect. So then that's complete. That's happy. Let's keep going to the next one. Good.
Okay. So we have iodine, which is fluorine, which is also 7 times 5.
Cool.
Okay, so this is guess I'm just gonna add that one there. And then we know that we need 7.
Good.
I don't really know what to do with that one. Okay. So I'm assuming this must be an exception. Yeah, the iodine. So that means that it's allowed to have extra. It's extended octet rule or something, right?
Right. And then double check. So does Did we add everything up to 42 electrons?
So don't I just say like 8?
Yep.
Oh, okay, so 8
Times the 5 bonds.
So it doesn't.
It
So I
doesn't.
have to
So,
add
yep, keep
lone
going.
pairs.
Exactly.
Okay, so I just do that.
Exactly. So when the outside, when we can't add any more, then we add additional, like the necessary lone pairs to the central. Perfect. And then that's why we always want to check the last one, or that last rule, just double checking if it does add up to the overall valence electrons, because if you stop there, sadly, that would have been wrong.
Okay.
Cool. This next one. Okay. You got this. Good.
Okay. So, I have to add them.
Mm-hmm.
Is it 14?
Yes. Good.
Okay. All right. Here we go. So, nitrogen over here.
Good.
Oh,
You're doing good. Keep going.
is that okay? Or do I have to like do
Double
something
check
else?
how many hydrogens you have.
Oh, which is happening? Oh, I'm just like adding extra ones. So I can't do 3 over here because that one goes with the oxygen. So it needs to be over here.
Yes.
Okay.
Good.
All right, here we go. So the nitrogen has 3. It's going to end up needing 2 more.
Perfect. Good.
And then the oxygen has 2 and it needs 6. So we're going to add that.
That's it.
Yay.
And then just double check. Do we have 14 electrons?
So 2, 4, 6, 8, 10, 12, 14. Yep.
Yep. Then we're good. Then we're done. Exactly. So perfect.
Awesome.
Questions about any of these?
No, I feel so much better about it. I understood the basic ones, like with just one element,
Right.
or even just like, without charges, but I started seeing these on like my homework, like these more complicated ones, and I didn't know how to do it, so I feel better now.
Cool. Awesome. How'd the practice problems go? Leave a comment below and let me know whether you got them all right or if something isn't making sense. I have several videos on Lewis structures and I'll leave them here, so make sure to check them out and I'll see you in the next video.